Hello, everyone. Welcome to our Pittsburgh.NET user group. You could join our group in meetup.com, pgs.net. We have a Twitter account to follow us. We also have a LinkedIn contact if you want to follow us on LinkedIn for all our user group related updates here. So we are delighted to have all of you here in call today, and we will discuss through the hacking C# development for truly lazy. During the next hour, we'll hear from our invited expert speaker, Simon Painter, who will share his knowledge and experience. He's also a seasoned professional, worked in the IT industry for a very long time. And we are very fortunate to have him here today. And he is from the United Kingdom. It's already late there, and he's taking his personal time to walk us through this topic. Thank you very much, Simon. The agenda for the session today is going to talk through the functional programming, Linq Generics, MetaProgramming, and then we'll have a Q&A session at the end of the webinar. So feel free to ask your questions at any point of time. You can ask your questions through the chat. And I will, without further ado, I will hand it over to Simon.
Cool. Ryan, hello. Hello, everybody. I'm keeping one eye on the comments thread, so please feel free to make whatever silly comments you'd like, provided you keep it all clean and nice and kind and friendly. Also, I have a list, so if at any point I say anything that doesn't make a great deal of sense, that may be because that's just me not making a lot of sense, or it may be because you just need me to say something again. So please feel free. I won't be offended. But hello, everybody. And yes, it is awfully late. It's 10 o'clock in the night at the moment, but this suits me in some ways because I've got small children, and so they're, in theory at least, all asleep down the corridor, which means I've actually got a bit of time to talk now. So where is the jolly old button? Right. Worries. Let's get with it. Again, break in at any time with questions and comments. So I like a bit of chat and banter as long as we keep it all civil. So a little about me, as our friend and host says, I have been in this business quite a long time. I graduated all the way back nearly 20 years ago now. I worked for a number of different industries. I've worked for the outsourcing contract for the HMRC, which is our tax folks. I think you have IRS in the US. I worked for the Works, who are a very known brand of books and other things here in the UK. An American manufacturing company, Protolabs. They're based in Minnesota. They're a very nice place to work indeed. Briefly, I was one of those contractors that your mum used to warn you about. And these days I work for Müller dairies. I don't think they're known in the US so much, but Müller are very well known in the UK, particularly for their yogurts. They do a rather hello. They do a particularly lovely which is sort of 3/4 with a little quarter of fruit or chocolate or something like that. So these days, and they're also a very nice place to work. That's me. An idea who I am. Here's a link to my Twitter. If anyone wants to grab it, wants to speak to me again after this. But yeah, there you go. So moving on to the actual talk. Hello, .NET Foundation. This is, according to me at least, the great debate of our time. We have two here. One's pretending to be a teacher, but honestly nobody. But two men here. One is straight-laced and serious and everything by the book. The other is the sort who takes it easy, does put a great deal of hard work into anything. Of these two men, which has the more fun? I'll fly around in the flying cars and see sleep with his don't do that one actually, but yeah, generally I would say the one to admire is the one who takes it easy, who doesn't put a screw hard work into everything. And that's my aim when I do my development work. That is, yes, Marty McFly. That's right. Good film, this one. I am just waiting to my corner to see it. But yeah, by which I don't mean that deliver everything we're supposed to deliver, because we should. That's our job at the end of the day. But rather, I want to do it with as little effort as, frankly, I'm lazy to do everything the long way. That's kind of what this talk in a long rambling way about. Ways of delivering the same quality and same quantity of requirements met, but with as little effort as possible through various little bit of tricks and tips over the years. So a project, think about it, roughly goes through these phases. I'm simplifying a little bit. We gather requirements, design a solution, code it, test it, and then provide enhancements. And which of these can we actually do something about in terms of reducing the amount of time required? Now, gathering is typically a job or an architect or whatever. Design may or may typically not. Coding, go developer, bang. Testing, a little bit fuzzy on these days, but typically not. And then enhancements. This, in fact, is where a coder, any given project spends the vast majority of its life is developing enhancements. Now, if I were a person asking for shows, I'm willing to bet that there are people who have maintained code bases upwards and more. The initial development effort is most software products. I'm noticing my disappearing. I will just try plugging in manually and see if that makes things any better. Voice is breaking really badly. Okay, is this any better? I've just plugged in manually to work port, so hopefully that. Okay, so yes, of these, there we go. The ones that as developers we spend the majority of our time working off is coding and enhancement. And of the enhancements is by far and away the one that we spend the vast majority of our time working. In fact, in field development.
Simon, sorry to interrupt. Like I think the voice is chopping off a lot. Not sure if
like I said, I've just plugged in manually. If it comes to it, I'll kill my video feed in the hope that that improves things.
Yeah, try that out because people already are saying that the voice is breaking.
Okay, sure. Okay, right. I've turned the camera off, so no one has to put up with my ugly face anymore. Could if anyone will be still very choppy? Okay, even with the camera off, is it still choppy? Hopefully not too bad now. There should be. I'm plugged in direct. Yeah. So as good a signal as I can get you at the moment. I'm not seeing anything, so fingers crossed. I'll put better now. Good. Okay, marvelous. That's great. Thank you. Oh yes, I've got a whole load of betters now, but I think there's a small delay in the comments thread, perhaps. Right. Good. Anyway. So I'll just good, better sound now, and also none of you have to put up with looking at my face anymore, and that can only be a good thing. Right. So I'll just restate this slide, and then we'll push on. So the point is that as software developers, the two places that we can spend our effort trying to improve how much time a project takes is in coding and enhancements. And of these, by now his face is glitching, can't see it. No, I've switched my camera off, Langy. And of these, the vast majority of a project's time is taken up in enhancements. I've certainly worked on code bases that were 20 years and more old. That is not an unusual thing, and I'm sure there's plenty of people for whom that's also true. And there we go. The problems that tend to emerge, at least in my experience, with regards projects tend to be something like these: unclear requirements, project management issues, and legacy code base. And of these, there's only one of them that we can really have much of an impact on. I mean, unclear requirements is between you and whichever BA you believe in. Project management issues, that's between yourself and your project manager. But the legacy code base is an area where we can have an effect to try and speed things up a little bit. And the biggest problem with the legacy code base is looking at the code and trying to work out what on earth it actually does. I have worked on code bases, and I'm not joking, where there were functions that were up to thousands of lines long in a single function. That is just a single function, thousands of lines long, with fairly broad names like do stuff. Maybe slightly better than that, but you get the idea. And this is not unusual, particularly with older code. And this is one of the things that tends to make it really hard to actually put your enhancements together. I have workplaces where there were boxes, input boxes with simply 3 rules that determined what the contents of this box was or should be. And the business would say things like, we just want to add 4th rule on. Well, yeah, dead simple, except when you dig into it, those rules are spread all over the place between multiple levels of DLL. And some are in the database and some are in stored procedures and so on. And actually determining where even to make the change is half of the battle. I worked for a company not long ago where simple changes like that would come in, but the code base was so all over. It would take a day or so just to work out where to make the change, and then the change might be just a line or two. But the battle was getting to the point where you knew where to put the line. And that's the sort of problem I'm trying to combat here. So according to me, the parts of a function are roughly this. There's the parameters, which is the stuff coming in. There's the return value, which is the stuff going out. And then in between that, there's actually kind of 2 things. There's the code structure and business logic. Oh, and Mansur Ben Kyle, apologies if I haven't mispronounced everyone's name. I'm doing my best. Testing, yes, I agree. Testing does add an awful lot of delay onto projects sometimes, particularly if it's manual testing. That can become a bottleneck. I agree with that. But as a developer, there's not necessarily anything I can do about that. That would be, again, in someone else's hands. But yes, in the middle, though, of our function, we've got kind of 2 ideas. Code structure and business logic. This is what I'm calling them. Business logic is what the function does. Business logic is what we are trying to achieve. And the code structure is what makes up how it is achieved. That is the details of how we achieve what we're trying to do, but not necessarily what. I'll show some examples shortly. There we go. So in audio engineering, there's a concept of the signal to noise ratio. The signal is the thing you're actually trying to listen to, and the noise is whatever unpleasant things come along with it. On a cassette, it's a hiss. On a record, it's a rumble. On a Justin Bieber album, it's the album. An unpleasant thing that you don't particularly want to listen to. Yeah, and in coding as well, I would say that this concept, the business logic, the what of what we're trying to achieve, is what is crucially important. That's the bit that you for. And when you tell them what this function does, the business logic is what you say. And the rest of the code that's irrelevant to this business logic is noise. And so in the next couple of sections, what I'm going to try and do is show you methods of reducing or eliminating the noise in the hopes that it makes the signal clearer. So part 1 is eliminating noise on the micro level, on the line level. So this is a function. Everyone's got 5 seconds to tell me what on earth this function does. There, but it's not easy. I would say that really what on earth this does in more than just a couple of seconds. Now, that's because there's an awful lot of noise going on. Now, what this is doing, actually going over the app settings, getting there to see whether they have a value, or then if they don't, then we're applying description. And each of these clusters of code represents a setting. There's 1, 2, 3, 4, 5, 6, about 6 lines or so for each setting. Which means that if we ever add a new setting, and we're going to have to add another 6 lines of code, check it, make sure it's all correct, and so on and so forth. So that's quite a lot of code to do a relatively simple task. Well, what we can do is pop in a like this. So these attach to strings because settings tend to all come. And then we'll ask for a default by type, either integer or string. Now you can add a load of these depending on the types it is that you wanted a decimal, then that process, frankly. Do the string is null or white check. In the case of the int, also do a check against whether it parses or not. And then return either the value that you've just parsed out of it, or if it didn't correctly parse, if it was blank or whatever, then return the default. Which means that we can replace the entirety of that function on the last 2 slides ago with simply this. Technically 1 line of code now, one really, 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 really long line of code, but still 1 line of code. Each app set has got what it does. You could probably show this to your non-technical boss or colleague who was doing necessarily down this, but there's still in print if you've applied the wrong deed or the wrong app setting or something like that. So it's what this has done. That's because I've eliminated all of the noise. An awful lot more easy. I want to add in a new app setting. It's just another single line. Oh, my voice is chopping up again. I am sorry about this. I don't know where it's coming from. I've done this any number of times, and today seems to be the day that it doesn't work so well. So apologies about that. Do let me know if I need to repeat something. If that is unfortunate. Okay. Apologies for the choppiness of the audio. Could well be a network issue. I don't know. If it gets too bad, I don't know. I think we're talking about taking a break and switching computers. But if it's network, then there may not be anything much I can do about it. So, if anyone needs me to repeat a section, I shall go back and repeat it. Hopefully, everyone's all right for me to continue for the time being. So, I've come up with a set of commandments for extension methods. Extension methods get a little bit of a bad rep, but yeah, better now, carry on. Extension methods get a bit of a bad rep, but I don't think that's entirely deserved. I think extension methods have their uses, provided you follow these commandments. And when I say commandments or rules or whatever, I mean, as always with all of these things, it's a matter of what you are trying to achieve. But broadly, I think that the rules I'm going to spell out are pretty good ones for the use of extension methods. So first off, no business logic. The whole point of an extension method is to hide away embarrassing or annoying code that you don't want to look at. It's like a snarf action figure that you've got hidden in a box that you've had ever since the late 80s. You don't necessarily want anyone to see it. You're glad to have it and keep it in a box where no one has to see it, but you have it. And that's extension methods. They're bits of code that you want to hide away. But business logic is the purpose of any given function or module or whatever. And that should be right at the front where everybody can see it. So never, ever put business logic in an extension method. That way madness lies. And keep them compact. If I can, I try to keep them down to a single line each. There are the odd case where I can't, but that is roughly my goal, to keep them as small and compact as possible, because the moment you start to put more than a few lines in there, it's sniffing like you've started to put some sort of business logic in, and once again, that's a thing to avoid. Keep them generic, ideally with a T. If you put a T in there and reference from a T that is a generic, then it affects everything in the entire code base, and you've made that really incredibly generic, which means it's more reusable and potentially more useful. And keeping them portable, meaning You should ideally have a little bank of extension methods, I certainly do, where you can just pick them up from any code base and drop them into any other, and they may still have their uses. So keep them entirely independent of whatever code base you're currently in. And I use them to get rid of boring, repetitive code. So whenever I notice myself doing a bit of boilerplate more than once, that's often the time to start picking up an extension method to carry the heavy lifting for me. And then finally, make them actually useful. I have spoken to somebody once when doing this talk who told me that they worked for a company that had an extension method is true, which simply returned true. I'm not sure that's entirely useful, but fine. You get the idea. Put them in when there's something to be achieved, when you can cut down on a bit of boring boilerplate code. So there's a couple of other examples of extension methods that I have used over the years. Here is a generic parser. So this takes a CSV file content, split it by line, and then split each line based on some sort of commas would typically be the one, whatever separates the fields, remove empty entries, and then there we go, an enumerable of strings ready to be turned into something more meaningful. Something empty if null. This checks an enumerable, and if it's null, then we'll return an empty. It's just avoiding the necessity of doing null checks. We can just call empty if null and convert a null into an empty, which is a lot safer to mess with. And similar with is not null or empty. So we're not only checking against null, but also empty. So it's the sort of thing I might do on a regular basis, and this extension method saves us from doing any of that. Now, I love dictionaries, and I'll get back into dictionaries again later. And dictionaries are good, but they have some problems as well. I love the lovely, concise syntax that you get when you use them, but for one, there have this annoying syntax for creating where you have to, if you've got a key value pair, you still have to do two separate arrow functions, one to select the key, one to select the value, even though it should be patently obvious. So quick extension method to handle that. So there we go. An extension method to turn a key value pair enumerable set into a dictionary, and another one to with a key value pairs there. Yeah. So that's just saving me a little bit of annoying boilerplate code. It's a little saving, but it just makes my daily coding ever so slightly less annoying. This is something I do sometimes as well, and that is convert an enumerable into a group by, and then group by whatever the heck the value is, and then put that in a dictionary where we've got the key value and the count. So what if you've got a whole big like enumerable of, I don't know, strings where there's a lot of repeated strings, you want to know how many of each, then call this method, and what you have is a dictionary where you can just call dictionary with the square brackets, put in the value you're interested in, and it'll tell you how many there are. So it's handy for generating reports. So that was line level. Those are just examples. There's plenty more. This is where a little bit of creativity is required to come up with more. But moving on to code structure noise. So this is a slightly grander level now. So I did used to work for an American company, and there is a cliche about British folks that we like to talk about the weather. This is entirely true. We do. The weather in the UK is a constant source of amazement to us. It is entirely possible to experience 4 seasons in a single day over here. And we typically prepare for all weathers because we often cannot be sure which we'll get. So I would talk to my American colleagues about the weather, as I am wont to do, and they would say things like it is 100 degrees outside, and I would think 100 degrees, that's the boiling point of water. You should surely all be dead by now. But no, of course they mean in Fahrenheit. In 100 Fahrenheit is, I'm not quite sure what that is in Celsius, which is what I work in, 32, something like that, something kind of pleasant. And the process for converting from Fahrenheit to Celsius is something like multiply by 9, divide by 5, add 32, something of that sort. And then I'm going to do a little bit of formatting to make it look nicer, add in the degrees Fahrenheit on the end. So yay, that's nice. But this isn't great. There's still some repeated stuff going on here. I've created some temporary variables to store intermediate steps. Now I could convert all of this into one gigantic formula and return it like that, but it wouldn't look very friendly for a start. So there's got to be some sort of better way of doing things like this. And here we go. It's called map. This is one of those handy little tools that I never realized how much I needed until I started using it. And this is an extension method that attaches to a generic key input, which means that it attaches to absolutely everything. And then it takes a func as the second parameter. And a func, I'm hoping everyone understands funcs, because there's going to be some more talk of funcs as we go along. And this func turns whatever the input type is to some other type, and then simply calls that function, passing the this into it, which looks kind of strange, but then you can do stuff like this. So I've turned the entirety of my to Fahrenheit conversion into an arrow function, and then just called map to do each of the transformations. Multiply by 9. Oh, there's a mistake there. Just ignore that. Add 32, and then do the conversion. So none of those intermediate variables are needed. We've still got the nice step-by-step look of the thing. And this sort of approach scales up very well as well if one of those, say, were a highly complex object that required a lot of memory or a database connection or something of that sort. Because if say, that second step was some sort of database operation, then it is out of scope the moment that map function completes, and subject to garbage collection, even as far on the next line, which is adding 32. So we're saving ourselves ever storing anything for a moment longer than necessary. Now, this is an incredibly simple, super duper simple version of something called a monad in functional programming, but I'm not going to go any deeper than that into it. But it's a tool that you can use to try and save yourself, again, a little bit of messing about. And if you wanted to stick something in the middle of it, to put a log in or something like that in the middle of one of those chains, because that's often the criticism given against those sort of chains of functions, you can use something like this. This is T. I've also seen these things called taps. And once again, this attaches to a T, meaning everything. And it takes an action. Now, an action is a func which has no return type. And what we do is call the action, do whatever's inside it, and then return the original this unmodified. So it means that it can sit in the middle of the function like this. So I can do my, once again, there should be a 5 in there somewhere. Oh, well, it does not matter. You get the idea. So it sits in the middle of the thing like this, and then right in the middle, we can log whatever the contents of X are, which will be actually multiplied by 9 divided by 9, so that'll be just the original value back. And then I'd carry on. But we've got a log at that point, is the point. So that's the, I find that kind of handy. Here's another example of things you could do. So if we try doing something like this, so I've created a hypothetical string which is prepending hello. So if it got a string which had my name in it, then it would say hello Simon or whatever. So, and then I'll do 2 calls to get person. Now, what get person is, who knows? It could be a database lookup or a flat file lookup or anything, an API call. It doesn't really matter. The point is, it's some sort of thing. Now, the problems with those sorts of lookups is that they might return a value or they might not. So get person, the first one's clearly looking up the number of the beast, and the second one of the other number of the beast. And in my example, one of them is returning a value, which is not null, and the other returns a null. Now, if we call prepend hello each of these times, the first time this works with person 1, that's going to work just fine. It will say hello whomever. And the second time, what you're actually going to get is an explosion. You're going to get a null reference exception because it returned a null, and that's no good. So what we'd end up having to do is something along these lines, doing a default check and checking against null and so on, and only then calling. So what we've done is introduce a whole load of code structure noise to what should otherwise have been a nice, simple little function. So I've prepared a function, an extension method called do if not null. So what this does is attach once again to everything and take a func, which, like the map, converts one thing into another thing. and then does an equality comparer check. Now, this is a scary way of just simply doing a null check, in effect, because when you are using generics for this sort of thing, you can't do a null check because not everything defaults to null. Integers don't, they default to 0. Booleans don't, they default to false. And there are other things as well, but most stuff that we're likely to run through this are going to default to null, but still, it's a generic check, so you can't assume. So what this is saying is, if whatever we have just called this from is not null or default, then you may call the function. If it is default, you may not, and you can just simply return default back again. That means I can do something like this now. So in my person one, which actually is as it happens has a value called do if not null. Inside that it does a default check against person one, which is not default. Therefore, it can execute the function. So the prepend hello is called. In the second one, which is a null, it'll do the generic check against person two, find that it is default null. In which case, even though I've passed in the prepend hello arrow function, it will not execute it. So we can safely define a single set of actions, and we don't have to worry about the null check because the null check is now built into the structure of our code. How am I doing for choppiness? Is anyone able to comment on whether am I still intelligible in as much as I ever am? I'll give everyone a moment to reply. Not seeing anything. Bala, am I making sense? Okay, I will push on until I don't see it. Oh, yep. Thank you, .NET Foundation. Thank you. Right, good. Let's move on. Excellent. Thank you, folks. Right. I am a big fan of the British TV series Doctor Who, and I don't know whether it's all that well known in the US or not, but just in case you've not heard of it, it is the best TV series in the entire world. It actually is. If no, I'm not making doctors. I am making the Doctors Who. Yeah, thank you. Yes, Johnny, you have good taste. I also love Doctor Who because it is, as I say, the best. If you look in the dictionary under best TV series, it literally is defined right there. So let's say, for the sake of it, that I'm putting together a dictionary. Now, once again, I love dictionaries. Dictionaries are useful. And I'm putting, for whatever reason, a dictionary which is going to, given the number of a doctor, now in Doctor Who there are many people who played the main role. There have been sort of 14 or 15-ish to date, depending on where you're counting from. But these are the first 5 for the sake of argument. So and in my totally imaginary example, I'm going to create something like a doctor lookup function, which is going to take in the number that you were interested in, and it'll tell you what the actor was, what the actor's name was who played that doctor. So if you put in 1, then you get the name of the boss, William Hartnell, the first Doctor. Now, with the dictionary, if you popped in a number that doesn't exist, so for example, get Doctor 100, there have not been that many as yet, depending on how you count. But for the sake of this example, that haven't been 100. And so, in fact, what a dictionary will do under these circumstances is throw an exception. It's something like a key not found exception or something of that sort, which is a great shame. It's something that I've never really liked in dictionaries, and I don't like unhandled exception. Because once again, it forces us to do an awful lot of checking against null and the like, and putting try catches around it, and stuff like this, which is just adding to the load of stuff that we have to add noise into the code to deal with. So there are better ways of doing it. Here's one for a start. This is something I call on dictionaries all the time when I use them. So this transforms a dictionary into a lookup function. So if you notice, hopefully it's visible on the screen, there are 2 arrows here in this function. Tom Baker is the best. I'm actually a big fan of William Hartnell and Sylvester McCoy myself, and I did very much like Peter Capaldi recently. So there are 2 arrows here, if you look. This is an arrow function that's returning another arrow function. and the arrow function we're returning is what goes out. So if you look at the return type, it's actually a func, and it's a func of the key type, which in my case is an integer, and then the value type, which in my case is a string. But what my func is actually referencing the original dictionary. Now, the original dictionary is no longer going to be referenced in the outside world, but so long as this func is in scope, the dictionary will be held in scope as well. But with this arrow function acting as a gatekeeper, sitting on the outside and deciding whether a request into the dictionary should be allowed or not. Because what it does is it does a try get value, which means try and get the value out of the dictionary if it exists. And if it does exist, then we'll have it. And if it doesn't exist, then we'll have a user supplied default value. Or in the second example, we'll simply return whatever default is, which is quite often null. I don't like nulls, and I will do anything I can to avoid the use of null. So I always prefer the first one. Let's give a default. And if we apply this to the get doctor function, let's create a dictionary. We've got our dictionary item, so the integer key, string value, and call toLookup with default and say don't know, which means that with the first one, we call get doctor1. Now it does behind the scenes, this func runs a try get value, and it finds a 1 exists, so therefore we return William Hartnell, the awesome man himself. The 100, it will find there is no value, therefore we'll return the default, which is don't know. So what I've done is I've transformed a dictionary into something that will never throw an error in theory. And the only difference is that rather than using square braces, we now use normal curved braces, because this is a function now, not a dictionary. But we've gotten away from this rather annoying behavior of tending to explode if you don't find a value, which gets rid of an awful lot of boilerplate code. Now, we can still take this process a lot further, because why not? This is the sort of thing I do when I'm bored. Let's imagine for a moment that I want to make an array of the first, third, and fifth Doctor, which would be William Hartnell, John Pertwee, and Peter Davison. It's fine. For whatever reason, I need to do that. But so this is all right, what we've got here. It's not terrible. It's a couple of lines of code, but a lot of repeated calls to get doctor, which don't really need to be there. So there are ways of getting rid of boilerplate even to that level. For a start, we can stick an indexer on this doctor data class, which means that we can now use square braces around whatever our arbitrary class is, and then we've gotten rid of the get doctor calls. It's now just dd1 with square brackets. That's great, but we can actually take this even further. Because did you know that you can apply params to an indexer? Because you can use params, which is an unlimited number of parameters of the same type, which will be popped into an array. So what it means is that we can call dd square brace 1, 3, 5, and that is entirely equivalent to the original function with its 3 calls, because it'll come into the doctor data class as an integer array, which we can then call select on and then get our values out. So sorted. We've reduced the amount of boilerplate right down to just about nothing. Philip, this should be a class with an indexer. Yeah, well, that's basically what I've just done right now. I wouldn't argue that functional is nonsense. That's a little unkind. I'm a bit of a fan of functional programming. I'm not going to be dwelling too much. Yes, I didn't know this either until relatively recently. But yeah, isn't this handy? Now, the number of times that I ever find an opportunity to use this isn't many, but it's a bit of absolute wizardry if you ever find a place that you can. So, right. Now, unfortunately, there's a video on this one, which I don't think is going to work with the technology we've got, but I've got some screen grabs from the relevant parts. So let's imagine that we are putting together a report, and it's an average report of property 1. Now, what property 1 is, it doesn't really matter. Maybe it's sales figures, maybe it's the number of fidget poppers we've sold this year. It doesn't really matter. But the point is that we are going to get some data from wherever we get it from, check whether there is any data, and if there is some data, do a group by and then select it out into a nice report and transmit that by whatever method, email perhaps. And if there was no data, we'll send a message to say there was no data this month. And finally, we've wrapped the whole thing into a try-catch so that we also won't get any unhandled exceptions, because once again, I don't like unhandled exceptions. That's fine. That's absolutely fine. But this, there we go, needs to be unit tested. Now we'll do a positive unit test. So we've covered the first block of lines of code, and then we'll test the data missing case. So there we go. There's some more lines covered, and then finally the throwing an exception case. So that's the whole thing covered. That's pretty good. We've done a good job. We've unit tested. We're sure that this thing works. But when you look down at your coffee, you notice that, like that scene in Jurassic Park, there is a ripple appearing in the drink, and the reason is that your boss is approaching, and and your boss now wants you to create a new function, and the function is going to be the same thing again, but with property 2, whatever that might be. Now, okie dokie. Now, what's the easy way to generate property 2? Average report is, well, this is where your function would come in, but video would come in. But basically, the idea is, I've screen captured here, you take the original function, copy it and paste it, and change every reference from 1 to 2, and there we go. Job's a good one, isn't it? Isn't it? Well, there's a couple of problems. For one, the unit test coverage of the property 1 was 100%, but what's the unit test coverage of number 2? It's actually 0. It doesn't have any unit test coverage, so we'd also have to duplicate all of the tests. And the problem is that you are replicating another function again and again and again. I used to work for a company where there was a rule base that they used every year to do certain calculations with. And for various reasons, the rules changed each year, but they still had to be able to go back to any old record and any old reference to be able to recreate the calculations according to the rules of that year. So we had to maintain all years, each with their rule base, separately at all times. And the 1 year that I was working there, it was my job to create this year's rule base, which, you know, was basically the same as the last one with a couple of changes. So I did what everyone else did. I copied and pasted, made a couple of changes, and then referenced it as year, whatever the current year was. And that seemed fine, except when I had a closer look, I noticed that there were bugs in the code from the previous year. And I thought, oh, now I'm going to have to update two of these rule bases with all these fixes. Great. And then I got a horrible cold sensation down the back of my neck when I thought, how many years have these bugs been simply copied over? And it was something like 10 years. So that was an awful lot of years worth of rules, all of which had simply been copied and pasted over without checking, and all of which had the same bugs in every single time. So rather than ultimately saving effort, in fact, we'd added to our effort in terms of the number of fixes that had to be made whenever a bug was found, the amount of testing effort that had to be made, because you have to test all of the years that were affected by the change. You can't just test the latest one. You have to test all of them. So the amount of effort actually skyrocketed. David Tennant's back. Yes, I'm looking forward to that. And Shuti Gatwa is coming at the end of the year too, and I'm also looking forward to seeing him. So I don't agree with this approach at all. Long story short, I don't like the idea of copying and pasting. I think the moment that you have literally copied and pasted a piece of code like that, I think something has gone wrong somewhere. And so I tend to favor an alternative approach. There are better names for it, probably, and in fact there is. I've since found out the proper word is funk, which sounds great, funk, It's the noise that a plank of wood makes when someone smacks me in the head with it. But I call them donut functions. Donut functions is as good a name as any. And yeah, and data fixes when data's corrupt. Yes, that's another good point, because if you've got a whole load of 10 years worth of corrupt data, and James Curran says, I once dealt with a code base which had the same bug, copied and pasted 45 times. That's beaten my record. That's incredible. So absolutely, this is a phenomenon. But a donut function, according to me, or a func, if you want its proper name, is it's a function with a hole in the middle. It's a great big function where there's one bit that tends to change each time that you make a new one of these, and in those you add a hole. Or yeah, we've got a video that's missing here, but it's all right. I have the screen grab. I use a func. So basically, use a func to be the missing piece that you want to fill in. Now, literally, the only difference between my two generate average reports was which field, which integer field, as it happens, did we want to make the report on. So there you go. Make a func which says, given my sum data class, the source class, which integer field do you want? Now that might be, you can make that a sum data to int or a sum data to object or whatever. There's only a number of things you can do there, but this means I only have to write one. I'll end up with two generate average report functions, but I only write one. And you could do something like this. A generate prop1 average report is actually just a reference to the generic version, but with an arrow function that tells you which property, and the same on property 2. And I would even ship that. I wouldn't have a problem with that. But personally, I might even consider simply exposing the func as part of the interface, and in perpetuity then allow anyone that uses my code base to select for themselves whenever they use which thing they want to generate a report from. I might do that too. This is this is up to yourselves, but I find this approach an awful lot better. And actually, when you think about it, now it really is incredibly easy to throw as many of these average reports as we want at this thing without making hardly any effort at all. This is working smart, not hard, as one of my colleagues says. So that's the approach I like. Here's the problem when you fix a bug and the user asks, why did you remove that feature? Yeah, I like that. It does happen. Another example. Now, I'm not a particularly big fan of Entity Framework. I'm sorry if anyone here happens to like it, but I don't. But this gets around some of the problems I find with it, and that's things like making sure that you've got a using statement around your creation of your data store and calling toArray at the end of every query, stuff like that. I've made myself a generic entity framework query here with a try catch around it as well. And I wouldn't really do a throw with nothing inside it. Don't really do that. This is just example code. But this means that I can now use a func to say, which is queryable to queryable, which means I can do all of my entity framework querying, but I can trust that the try catch will be done, the using will be done, because I have worked at places where they have entity framework embedded firmly throughout the code base, nearly from end to end, but weren't calling toArray after every query. And so what you were finding is as the code base ran, it was gradually slowing down because more and more things were being added to memory, or sometimes toArray wasn't being called inside the using, it was being called outside, which can sometimes cause unexpected errors to happen because you've no longer got a live database connection, and strangeness once again. And this forces that to be safe. So it's a quick little save, but referencing the entity framework through this saves you from all those sorts of problems. I probably should make that extension method as well. So let's get part 4. Let's get funky. Aren't I funny? Ways to use funcs in slightly creative ways, because funcs are one of the more powerful features of C#. They can do some pretty strange and interesting things. So here's an example of something I might do to validate a username. We need to check if it's, first off, is it a null or a white space? If it is, then return false. That's not a valid username. Is the length less than 2 or greater than 20? Then we don't consider it valid in my arbitrary rule base. If it's Justin Bieber, then it's not allowed because it's simply not. And after all of these ifs, where we return false early if the rule doesn't meet, then finally at the end we return a true to say, yeah, this one's actually pretty good. That's fine, but a lot of repeated code noise here, which isn't necessary. And one way to get around it is something like this. This is a generic validator. You attach it to T this, so that's everything again. It attaches to everything in C#. Params, because once again, I cannot be bothered with instantiating new arrays when params will save me from all that rubbish. And I take a parameters of funcs. So the funcs turn T, whatever T is, any type, it doesn't matter, and turns it to a bool, meaning is this valid? Yes, no. And then call all on this. Now all is a Linq method. And what all does is execute whatever's inside the all, whatever's in the arrow function, which in this case is simply take this and feed into one of the functions in the predicate array. And all requires that every single instance of the arrow function it's passed returns true. And if a single one of those returns false, then it terminates early. So this validate is a complete replica of all of that structure that you saw on the previous slide. And this is the updated version of the validate username. We can now simply say there's the string we passed in, and on that string we'll call .validate, and then give it a series of arrow functions. And inside validate, it will run these one after the other until one of them returns false, in which case we'll return false, or until we reach the end, in which case we'll return true. It took me quite a while to explain that, but not very long to write it. And adding new rules in should be incredibly simple. This is a potential upgraded version of my Fahrenheit centigrade conversion system. So aggregate is one of those bizarrely less well-known. Thank you, Ayasud. I hope I'm saying that right. I really do. Aggregate's one of those functions which is part of Linq, but doesn't seem to be all that well known. So what you do with aggregate is you give it a starting value, and then you give it something like a select arrow function, except there's two parameters. One is the running total so far, and one is the current item, just like your normal X in a select statement. And then it expects you to return the new running total. So aggregate gradually reduces an array of things to a single thing. And in my case, I'm giving it arrow functions which perform some sort of conversion. It's a decimal addition, subtraction, multiplication, whatever. So in my apply ops, we'll start off with a default of probably whatever this is, which will be the temperature in centigrade, which means that the first ACK, the first accumulator value, will be whatever that is. Let's say it's 32. And it'll run the first function multiplied by 9, which means the next time it runs, when we do divide by 5, then ACK will now be the original value multiplied by 9, and so on until we get our final result, which means that we can do multi-step operations without very much effort, and it looks quite nice. The only thing is, unlike my map function, we can't change types. We're stuck to a single type, so all of these must be decimals. But still, yeah, it looks pretty good. Another way you can use funcs is you can use it to reduce code structure like this. So a check to see what T is, whatever this T is, and then based on whatever that is, will return a new instance of that class. So this is basically like it's a factory. It's basically a factory. Whatever you've referenced T to be, that's what it's going to get you. And you can actually put types inside dictionaries, and you can put funcs in dictionaries as well. So what I've got here is a dictionary where the key is a type, and then based on the type, it'll return you a function which will instantiate a new class. Now, I've just made this incredibly simple for the sake of showing you the simplest version I could think of. But this might actually go and rather than just being a simple new walk or new fly or whatever, this could be referencing a function elsewhere in your code base or something like that. And I've also converted it into a lookup with default, meaning that if you ever feed it a type now that it's never heard of, it will return a default value of walk. So you shouldn't be able to get this into a state where it's going to throw an unhandled exception. Take a breath for a minute. Part 5. being lazy with enumerables. So enumerables are very interesting beasts, and most folks I know treat them simply like they're arrays, but they're not arrays. They're not arrays at all in many ways. Enumerables aren't even data, really. An enumerable is simply a pointer to data. So if you want, now, yeah, I can't draw. I'm not very good at drawing. Apologies for that, but you get the idea. Enumerable is actually more like this. An enumerable is a sort of box with two buttons. One says, get me the current one, and the other button is move to the next one. Don't do this. The compiler will optimize if statements. Dictionary will be slower, memory intensive. Maybe. This is an interesting point. Now, it all depends on what you're trying to do, how complicated your functions are, and how much code complexity you're saving. Now, in my ridiculously simple example, you're probably better off just leaving it as it was. But if you've got an incredibly complicated example with a lot of stuff going on, then there might be some efficiencies, not in terms of the efficiency of the running of the code, but in terms of how easy the code is to actually work with, how easy it is to understand. So these are one of the cases, this is one of the situations where it's down to you to make a decision, because if you could very slightly reduce the efficiency of the function but massively improve the readability, I'm typically still in favor. Reason being, these days we're not like the old days where there were physical servers all the time, and the physical server needed a physical RAM chip and physical CPU. These days, pretty much everything's virtualized. So ask yourself, which costs the company less money? Pressing a button somewhere and sticking a virtual RAM chip into a virtual server, or a day or so of your time? I would argue that more often than not, it's very easy to throw more RAM at something. But if by staying with a more complicated coding example, it takes more of your time every time they want an enhancement to it, that's actually costing the company more money. So I would always argue that even if it's not the most efficient way of implementing a function, if you can make it easier to work with, it's often the better choice. Again, depending on what you're trying to do. There's plenty of examples where that's not the case. If you are, for example, trying to make a VR 3D game, you probably really do want to focus on efficiency above absolutely all other concerns. But for most of us, when we're just writing sort of mid-range business software, which is typically converting data from one form to another and moving it elsewhere, then I would say go with the most maximally readable, easy to maintain version rather than the maximally efficient, to an extent. Depends what you're trying to do, as always. But back to enumerables. Yes, James Code, you're right. Enumerable is a data generator. That's another way of looking at it. In my head, it's a pointer. It's not the data yet. When it's an enumerable, all it is a pointer saying the data's over there somewhere. And it isn't actually data until you enumerate. So in my very simple example, I've got A, B, C, and D as very short strings, and the current is now A, and if we call move next, then we'll get to B, and so on until we hit the end, and then it'll terminate. And this would still be the case even if it's incredibly complicated functions inside the enumerable, because I mean, it's in some ways that's kind of close to what EF is working like. There might be some sort of, each step of the enumerable might not be just go and grab this data item out of the array. Some of them are going to be highly complicated database lookups with multiple joins. So there are going to be times when we could actually make savings by not necessarily executing each and every step of the enumerable, because it might turn out that when we call things like wheres and similar later on, that it might be that some of those data items simply aren't needed at all. So depending on what you're trying to do, it is entirely possible then, though, to amend an enumerable without actually enumerating it. And that's what I've actually come up with a system of doing. Now, what I do what I want to do here is I want to substitute the third item in one of these from C to Z, or Z, as you say in America. What I basically do is create another enumerable referencing the first one, but with a gatekeeper function in the middle that says, should I do a substitution or not? And it doesn't actually do the substitution at that point. It only substitutes when you finally call the run it through a for each, or call toArray or toList, or whatever you'd like to. And it's only at that point that this sort of little cluster of enumerables collapses into a single value. If you call toArray and modify, on the other hand, you actually end up with two arrays, the first one and then the second one. So you've actually got two things in memory, which is a bit of a waste. This is my adjust function. So what I'm attaching this to an enumerable anything. I want a func. Now this func is the rule to say, should I do a replacement? So T being the current item, whatever that might be. It's a string in my silly example. Integer representing the position. So 0 for the first item in the array, 1 for the second item in the array, 2, and so on and so on. And then the bool, which is the return value from the func, is should I do the replacement or not? And then the second parameter is the replacement value. So if the current item is passed into the func and it comes back as true, then we replace it with the replacement. And then to generate a new enumerable to return back, we call this.select, and then inside it we run should replace for each item, and then decide to do the replacement or not. And it's this select generates a new enumerable. So potentially at this point, the original enumerable is no longer directly referenced. Now it's this.select, whatever enumerable comes out of that is referenced, and the original is kept in memory as part of this adjust function. So in this example, I've got A, B, C, D, and in the next line, array B, I'll call adjust, and I'm saying whenever I, that is the current position, is 2, A is 0, B is 1, C is 2, so that means it's C, replace it with a Z or a Z. And then the line after that, we'll call reference array A again and call adjust, and I'll say if the value is equal to C, then replace it with Z or Z. But the point is that when that third line of code executes, it still hasn't actually changed anything. The original array is where it is. No further lines have been called. And if I don't call toArray or do a for each or whatever, then none of these operations will actually be carried out. They'll just be chucked away because they weren't needed. Now, for a very trivial example like this, where they're just characters, why would I do this? But again, let's imagine that instead of simply characters, each one of these items requires some sort of large, horrible, colossal data lookup with maybe joining a couple of tables and who knows what. And so we're saving ourselves a lot of effort by preventing the need for forcing all of those items to enumerate when we don't need them to. So if it turns out we only need the first 3 later on, then we'll still do our replacements, but D will never be called and never be referenced at all because we never needed it, whatever D is. And it looks something like this. This is basically a series of filters. Each adjust call creates a filter sitting between the enumerator, which runs the enumerable process, and the source data. Now, once again, with a simple array, this is probably rather heavy-handed, but it has its uses. Now, of course, there is a memory overhead in doing this. Each one of these forces a little bit more stuff to be held in memory up until the point when you enumerate and collapse it up to a single value. So whether you do this or not depends on what you're trying to do and whether it is a good idea or not. But this process does exist, and it's here. You can use it. Another thing you can do, let's say that you want to look at consecutive numbers, but without actually enumerating the enumerable right now. That's also possible, but requires a little bit more hacking around. So this is numbers. So for this is a trivial example, and in the real world, I would never do this with numbers. Numbers is fine just to call toArray and just reference separate the consecutive step items inside the array. That's fine, but I'm keeping it simple for the sake of example. Once again, imagine that these were some sort of very complicated lookup each time. That's the sort of thing I'm trying to save myself some effort on. There we go. So the first thing we'd need to do is crack open the enumerable. So inside an enumerable is an enumerator. The enumerator is that actual engine, the thing with move next and get current that runs underneath the surface. And once you crack an enumerator open, you can create all sorts of strange custom behaviors to the way that your enumerable works. And I have done all sorts of things with these in the past. So I created an extension method, which is a version of any. So this isn't the Linq any now inside here. This is my any, which looks something a bit like this so far. I'm asking for a func, which I crack you up. I hope that's in a good way. I hope that's in a good way. So this is asking, so it's attaching to any enumerator now, and I'm asking for a func which has a t and a t and a bool. That is the current item, the next item, and a bool to say, are your rules met? And my rules are going to be, are they consecutive numbers? And then I'm going to call move next. Now, move next is interesting. In an enumerator, we start actually in position -1. -1 is before any of the data. So we start before we've even got the first item out. Then move next will return true or false. True to say I found another item and I've moved to it, so it's moved to the 0th position item, or false to say there were no items, it was a blank array. So based on that, I'll call any again, and this time I'm passing in whatever the current item is, and the func I'm just passing along, and this I'm just passing along. But the point is that I've gone to the first position, the 0th position in the array, or whatever it would be under the surface, and passed that along as a parameter to the next version of any, which looks like this now. This is our final bottom level any. So you remember that we called out the item at the 0th position. So now we call move next again. So now we've moved from position 0 to position 1. And now I can actually call the function. So prev is what I've called with the in the previous one where I got the 0th item out. So I'll pass in prev, pass in the new current, and then based on whether the condition was true or not, we could return true. Because this is an any, so the first time it hits true, then we return. Otherwise, we'll just do some recursion and call this ourselves. Now, I am aware that there are issues with recursion in C#, so I kept this simple and compact by using some recursion. The recursion then would allow us to call move next again and again and move through the array bit by bit until eventually move next returns false. You could switch this out for a for each loop or a for loop, and this no, you can't do that because this is, so what you'd have to do is switch this for a while true and then put returns inside it based on whether we ever meet our condition or not. So memory wise that would be more efficient, but I like to keep things concise, and if I know for a fact that my array is going to be small and there aren't many items, then this is safe. If your array is going to be thousands of lines long, then you want to change for a while. So as with all things, depends what you're trying to do. And that means I can create a contains consecutive numbers function that simply looks like this. So attach to any enumerable and call any, my any, with an x and a y, that is 2 consecutive integers. And then I'm saying y is equal to x plus 1, meaning they were consecutive. And spoiler, yeah, they totally were a pair of consecutive numbers in that first example. It took me ages to explain that, but it took me this much code to actually use it and write it. So moving on to our last section now on attributing. Attributes are a fantastic feature of C#, which don't get used anywhere near as much as they should. So returning once again to Doctor Who, one of my favorite topics. Let's imagine that we are trying to create some sort of data set based on episodes of Doctor Who. So this is, when I wrote this talk, this was the current season. We've had some more since then. Can't really remember, season 12, I think. And here's some data about in that particular season: the title of the episode, the number of the season, the number of episodes. Now it's always 1 as it happens here. or the number of the episode within the season, and the writing. So great, no trouble. It is actually also another item which I think was the number of viewers, according to the BBC, and that's fine. We can create a function fairly easily to do that, and it would look something like that. So parse through the string, split it on new line, and then split again on comma. We get an array of arrays out of it, and call toArray on that, and just to make it easy to work with. And then after that, do another select to say turn it into an episode data, which has got title and season is hard coded to 11. Oh, it's 11, my mistake. And the number of episodes is always 1, and so on. That's fine. There's nothing wrong with that. I have no issue with that. This would be code I would ship. But let's imagine now for a moment that we've decided to go back a season to will be season 11, and for some reason, completely arbitrarily for the sake of example, there was a slightly different data structure. Look, there's an extra, I don't have a finger that I can point with here at the moment, but there's an extra field there. It's the second field along, and it is the total number of this episode throughout the whole of Doctor Who. So, for example, The Woman Who Fell to Earth is the 277th episode of Doctor Who ever made, because it's been going since 1963. And that would throw off the parser that we created in the previous example, because now everything is shifted one place along. So, ways of dealing with this without an awful lot of repeated code. Well, option 1 is something like this. This isn't a terrible option. I might even accept this. That's fairly nice. So I'll create a dictionary, because once again, dictionaries are brilliant. And this will take a season number, 11 or 12, and then it'll return out a func, which is a converter function, which will turn your array of arrays into episode data. That's all right. That's fine. I'd ship that, to be honest. But once again, there's always better ways of doing these things. There. And there's my fairly generic parser. That's how I'd use it. So split on, and then you have to pass in give it the input, give the season number, and then based on that, we'll go to the converters and call out the correct converter for it. And it's still only one parse episode data function for both seasons, and that's not too bad. But that's where we could use attributes to start doing interesting things with it. So creating attributes is actually very easy. You simply inherit from attribute, simple as that, and then attach whatever data you want to it. So I'm going to create a couple of attributes here. So the first is season, to say which season number is this. And then the second is CSV position, to say within the CSV position for this particular property, where is it in the CSV file? Which position in the array of arrays was it? Then you can use it like this: create a single episode data class, an abstract, which means you can't instantiate it. You have to create an inherited version, but it gives you some defaults. And I can use the season number attached to the class to say this is the season number, so then that value is set there, and the CSV position. So the bit that changes is title. So now title, I've inherited it out, and I've said that in season 11 the title can be found in CSV position 1. That's the second item in the list, and in season 12 it's in CSV position 2, which means if we can pull that data into our parser class, then we don't even need to bother with our dictionary. We can do away with it altogether. My father hates Doctor Who, but Tom Baker is his favourite Doctor. Okay, fair enough. That's an interesting contradiction, but Tom Baker is pretty cool. And this is the code which is required to grab an attribute attached to a class. It's a little ugly, but fine, it's not too bad. So this will get a season number based on doing a bit of reflection, getting the type, getting the attribute, casting it correctly, and then pulling out the season value. But once again, as with all extension methods, it's a bit of repeated code that I want to hide. So I might want to use this in a few places, and this will get rid of some of that. So it's fine. It's getting rid of some code noise for me. And this is what you would need to get an integer value of a type, which, yeah, it's once again, it's not great, but we're hiding these at the back of our code base. So I'm showing you this just so you know, get an idea of what the code looks like. But by and large, you just need to write one of these, copy paste it, shove it in the back of your code base, never worry about it ever again. And then finally, this is for getting an integer value out of a property. Now, to get an integer value off an attribute attached to a property, this is really quite awful. And yeah, it's doable, but it looks pretty hideous. So copy, paste, shove it in extension method, pop it to the back of your code base, and never think about it again. But it means that to write the generic parser now, I just have to write something like this. I'll split on new line and then comma, call toArray so that I've got a nice friendly brackety format to get my items out of, and then create a new T so it's generic. I don't know which type, and I've enforced that it's a kind of episode data, so it must be episode data of some season or other, but I don't know which one. And it must have an anonymous constructor as well. I've also enforced that, so I know that's true. And then I'm going to say that season is equal to, and then call type of T and get the attribute value for season number out of it. Tell it, yeah, it's not great looking, but you even only need to write this just the once. But it means that whenever I need to add new season data in, though, the huge advantage is that all I need to do is create a new implementation of episode data, put the correct attributes on to say where the data can be found. And am I sharing this code anyway? I think it's already on GitHub somewhere. If it's not, I'll try and put it up. I believe it's already on my GitHub. There. So let's go back another step and say that there's some sort of wild difference again in season 10 for some reason. Well, there we go. Inherit, put season number tag to say it's season number 10. That's done. And then the CSV positions have to be specified, but I don't actually never need to write another parser ever again. Just every single time I need a new season's worth of data, inherit, season number, attributes where necessary unless the default is acceptable, and that's done. So barely any effort whatsoever. And you could even go further. You could even go to say that for any given season number, you could also specify what delimiting, what separates the lines. So maybe instead of new line, it's actually pipe in season 10. And maybe the fields are separated by semicolons or commas, maybe, who knows? But the point is that you can put all that stuff there. So everything that's specific to the season, you can make an attribute that specifies it. And anything specific to each field, you can put there. And then once again, same principle applies. Unless the default is acceptable, inherit off episode data, apply the attributes you need, job's done. You've only still got one parser function. The data has no headers. How do you mean? Sorry, not quite sure I understand, Mark Flug. Right. And this is finally the bit where I get to stop talking. So I think there is a small delay, so I'll just wait for a few moments. But I'm done with my presentation now. But does anybody have any questions to put to me before I go and retire for the evening? Given it's now. Oh, thank you very much. That's much nicer than mine. No header row in the CSV. No, there isn't in my case, but there could be in yours. I've kept my examples really ridiculously simple, so structure it as you would want. But I kept mine pretty simple. But yeah, you're right. Probably I should separate it out to something like headers and items. Have you looked at F# and what are your views on language? Oh, there's always one. There is literally always somebody who asks me this question. I do not know F#. I do not. It is on my list of things to do to investigate, to learn F# this year. I'm hoping to do it finally, and I might well get round to it. Now, F# looks pretty good from what I've seen of it. A lot of what I'm doing here is kind of replicating the sorts of things that F# folks take for granted. But the only problem with F#, but it's not a problem with F# itself, is just it is not used all that much in production, really. And I'm not saying that that's necessarily a good thing. It's just the reality. The reality is that everyone uses, by and large, vast majority of .NET developers are C# developers, and as such, that's why I tend to focus all my efforts on C# and trying to bring some of the features that might well be available in F# into C#. But anyone who likes this sort of approach and wants to take it a step further, go ahead and have a look at F#. I know a lot of F# folks, and it does look pretty good. And I know the F# guys that use it absolutely swear by it, and probably like shake their heads in scorn at us C# developers and our more difficult ways of doing everything. So, shouldn't a parser use code generators and spans? Yeah, probably. I'm keeping it simple once again. Will the stream be saved online? I don't know. I am not the organizer. I dare say he's around here somewhere. Bala? Oh, do I want to turn on camera? Yeah, I'll try turning the camera on, but if I get choppy, I'll switch it off again. Yes, it will be available. There we go. I've turned on my ugly face again. Apologies for that. There's nothing I can do about it. It's the only one I've got.
Yeah, it will be available on YouTube for later watching.
No problem,
A lot to
Sebastian.
digest at the same time, I would think, Simon. It might be worth watching again.
Do you have any examples where you don't mutate objects? For attributes, that's probably just about the only ways to do it. I try and do as little mutation as possible, but by mutation I mean changing of a variable once it's set. I am a bit of an advocate of functional programming. Oh, actually, if I could just beg my slideshow to be put on for one moment again. Thank you. I have a book coming out in the very near future if anyone wants to see more about functional programming. There's a URL here that you can feel free to scan and go away. And I think it's going to be published by O'Reilly probably in the summer, probably sort of September, October-ish actually time. And I think this URL will give you some months free on their platform. The early release version's available to read at the moment. There's about 10 chapters and there's some more going up soon. So this book's coming out. And I do warn everyone, though, it's got a lot of functional programming, but also a lot of really, really terrible jokes and references to Doctor Who, because there is no way that I don't do that. So thank you anyway. Sorry, I just wanted to make sure I'd got that shout out done. But when in the functional programming approach, the slightly pure functional, I have all sorts of ways of making sure I don't mutate objects for sure. I don't have one of this. This isn't my pure functional talk. This is just slightly functional inspired in places, techniques which will allow you to get your job done easier. Oh, you're very welcome. I'm hoping everyone's enjoyed the talk. Certainly, I enjoy giving this one. If I weren't talking to you folks, I'd be boring my wife about this subject, I dare say. So, any more? Yeah, thank you. I don't know if we're wrapping up, that's all right. But otherwise, I am on Twitter. I am on LinkedIn and all sorts of other places. So please, anybody at any point, feel free to reach out to me and ask questions. Oh, sorry, I missed that one. Blue Jet, which became Walmart's online sales site, is written in F#. Well, I'll be. Fantastic. That's really cool. Thank you, James Curran, for letting us know that. I did not know.
Thanks,
that's
James.
very cool. Yeah, that's well cool. I didn't realize, but there you go. So I must eat my hat now, because there clearly are big companies that use F#. So any last call for any questions?
Don't have any. Thank you very much, everyone, for attending the talk today. And Simon, thank you very much for staying late. And it's a real pleasure hosting you. Thanks, everyone, for joining us.
Cheers, everyone. Thank you. I do appreciate the opportunity to speak.
Thanks all.